Alright, so announcements. Alright, Project 1 due today. Hope everyone knows that. I hope all of you have finished. If you haven't finished, I hope it's just, some of the write-ups or something. So that's due by 11:59. You have to submit both your code, so your .m file, and then also a PDF. Alright, so you go here, and I only allow the .m file and the PDF. So, yeah, make sure you turn them in. And I'm going to go over a few of the questions that I've seen in Discord the past few days, too. And then, let's see, what else today? Let's go back. I just uploaded today's page. So, we have homework 6, that's due today. And we have quiz 5 at the end of class. I thought there was something else. No? Okay. I think someone has their mic on, by the way. Just to know. Let you know. Okay, let's go over the deliverables for Project 1, some of the questions. Alright, so there's been questions on the write-ups, right? I think that's the main thing. So the write-ups, you need to have a write-up for all of your code up to when you start making your plots. So let me actually open this up. So this is the homework from homework 6. So this is the for loop question. So basically what I mean when I say you need a write-up for all of the code up to your plots, let's take this as an example. So I have all of my code here, all the way down. So all of this that I'm going to highlight now, all of this that I have highlighted here, I want you to do a write-up on that, right? That's all of the code up to when I have my code to make my figure. So you have to do that. I know that's a lot, right? But if you wrote your code correctly, you would have your code in blocks of code, and you can write for that. You can write an explanation for that entire block of code. And then for the figures, you have 2 write-ups for that. So that would mean you need to have a write-up for the code for those 2 specific figures. Let's go back here. That's figures. Well, it's this figure and this figure, right? So are there any questions on that part? Yeah, Bemwa, only for the, you only need a write-up for the 2 figures for that portion. These 2 here. But make sure you have the write-up for all of the code up to when you made your plots. Alright, so make sure you also read through all of this before you submit your project, especially the grading breakdown, and you can see how I grade each section. So your report has to be, a document, so you can make it in like Microsoft Word, and make sure that I see that you have an intro section. So basically, look at report structure here, make sure that you have an intro, make sure that you show me your results / write-ups, so that'll be, a code block, then your write-up, a code block, then your write-up. And then down here, make sure you have your appendix section, and here you're going to include every single figure that you made. Also, you might be wondering why I have you include your figures in the report. One, it's easier for me to see right away if you made the correct figures, and if you weren't able to make all of the figures, I can see again at a glance which ones you were able to make versus which ones you couldn't. Alright, and then at the very end of your document, you copy and paste your entire code. Okay, plot format requirements, make sure you look at this too. Do as I say, not as I do. I forgot to update these to include the most recent date, so make sure all of your plot titles show the most recent date. And then the write-up example, so you here's an example, right? So basically, I have like a block of code here, and then in depth, I discuss what that block of code did. I mean, maybe not it's not super detailed, but it's more detailed than the comments that you have in your script. Okay. Yeah, so there's a question. Someone submitted their document yesterday, and then they submitted their M file right now. And can I see both? So yeah, I can see everything that you submit on Canvas, so don't worry about that. Alright, so before we move on, are there any questions on Project 1? Anything at all? I also make sure that you're using the most recent data that I uploaded for April 22nd. Nope.
I had a question.
Okay.
By what time are you gonna have them graded? Have the project graded?
I don't know. As soon as I can, but it's gonna take a while.
Oh, okay.
It'll be at least a week.
Oh, okay. And how harsh or how harsh are you gonna be with the coding and with the write-ups and stuff like that?
Yeah, so for the code, I mean, the code, it has to be correct, right? But I'm going to try to give you as much points as I can. So let's say that you were able to make one graph. I'm going to look at the code that you wrote in your attempt to make that graph. And I'll try to give you, as much partial credit as I can. Then for the write-ups, that's a big part of your grade. But to grade that, I'm going to see basically how well you explain stuff. Because the write-ups, I have them, so I know that you know what you're doing. So, that's the biggest thing. Can you explain it well? And then also, how detailed is it? Like, if you just write a few things and you don't address everything in that specific block of code, then I'm not going to give you full points on that.
Okay. And it's out of 100 points, right?
Yeah, it's out of 100 points, but that part it doesn't really matter. What matters is the weight for the class. So I think the first project is 25%. So you should look at that stuff. Look at the weighting for the stuff. Let me open it up.
Okay. Thank you.
Yeah. Let's get this though. So, homework is 15%, quizzes are 25%, and your first project, that is weighted for 25% of your grade for this class. Okay, there's a few questions. So, our graphs have to be the most recent data, and they gotta be the most recent data. How do you show your figures in the document file from your code in Matlab? So yeah, you just gotta export your figure. So we've gone over that at some point in the class. You can look at your figure, and let's open this up. We're gonna do this today, by the way. So if you have your figure in Matlab, you could just do File, Export Setup. You don't have to do this part, but I like to make it a good resolution. Then you click on Export, and then you save it as like a .png. Wherever that is, .png. So I have slides on that. It's probably in the plotting slides. Or you can do it in code by using export graphics. That was also shown at some point. Then obviously you're just gonna go to, insert picture in Microsoft Word. Okay, can we turn in the homework tomorrow so we can focus on finishing up our projects tonight? Okay, I guess. Yeah, sure. I'm not gonna be too hard on that. Yeah, you can turn in the homework tomorrow. That's fine.
Well, actually, Patrick, can we do that actually for everyone, not just the person you were talking to?
Yeah, for everyone.
Okay, all right. Thank you, Patrick, for being really patient with us during this time.
Okay. Is it okay if we just copy and paste it? Copy and paste what? The figure? You just got, I don't care how you put the figures in there. It just needs to look like I need to be able to look at it. Can you take a screenshot of the figure? No, I hate when people do that. It's a pet peeve of mine. Don't take a screenshot. Actually save the figure. Yeah, so when you save the figure, actually save it. Don't take a screenshot, because again, that's a pet peeve of mine. It just looks bad, okay? So actually export it like I just showed you, or you can use the export graphics command. Okay, someone says no quiz today. Yeah, there's still a quiz, but it's easy. I forgot to talk about that too. It's not going to be on the homework. It's going to be, because I know probably everyone was working on the project still. So the quiz is going to be basically feedback on the project. So that'll be available at the end of class, and then you've got to turn that in by the end of today. But you got to make sure you do it, right? If you don't do the quiz, then you're going to not get points on it, so make sure you do that. And it's only 2 questions. Basically, what did you like about the project and what didn't you like? Alright. Oh yeah, but I didn't tell you guys before because basically I still want you to actually have studied so you actually know how to do the if statement and for loop. Okay, now let's go over, I want to be reasonable, of course. Okay, before we get started on the nested for loops, we're also going to talk about project 2 a bit. My mind is kind of in a jumble now too from the project and my other classes, so sorry if it's a little scattered today. So, project 2, yeah, I didn't get any sleep last night either. Okay, project 2. So the deliverables for project 2, I'm going to upload that by Wednesday. Because I want to give you as much time as you can. I wanted to get it done by today, but I couldn't. I was too busy helping you guys mostly and doing the project myself. And then also doing my other classes. So anyways, I'll get the deliverables up by Wednesday, like I said. But this is what you're going to be doing. And I'm actually going to show you all the figures for project 2, just because it's more... I guess, well, the difficulty is harder than project 1. Just because it's looping, okay? Don't worry about it too much. Okay, so for project 2, you're going to make these figures here. And so here's one. We have COVID-19 cases versus the percent of population fully vaccinated. So we have a few new data sheets that I'm going to upload as well. So the percentage of people fully vaccinated, that's for the most recent date, so that's up to April 23rd. And then the one that started for the amount of cases that are recorded per million for that population, that started on February 1st. That might seem like a really weird date. That's when the data set starts for this spreadsheet. So, and this is actually kind of a cool figure too, because you can see, the people that are vaccinated a lot in general, they haven't had that many cases since February 1st. Again, this is the number of cases per million of that county's population. You have some outliers here. Mono is a really small town or a county, so that probably has something to do with it. If it's like if it's a densely populated small town. And then these over here, they're not that vaccinated right now, but again, they're small towns. So, that's, I think, has to do with that. And then these, we have some small towns up here too, but you also have counties like Riverside and San Bernardino that not that many people are fully vaccinated right now, and they have a lot of cases. Anyways, kind of a cool graph, I think. Next one. Percent of population fully vaccinated up to the 22nd of April. And this is sorted by the highest to lowest. So here there's only 15 counties that you have to do for this graph. Of course, the deliverables I'll be very explicit too. Alright, there's a lot of heat maps in this project, by the way. So here, percentage of population fully vaccinated over time. So this is like, day by day, what percentage of the population is vaccinated. Alright, so I think this is another kind of cool one. Let's go on. So, some of these are doing pretty well. Okay, percentage of population fully vaccinated over time. So this is another one. It's basically that same graph you just saw, but this is sorted by the top 15 for the highest amount of vaccinations. Okay, cumulative percentage of Johnson & Johnson doses given. There's hardly any of them, right? I mean, even regardless of how they paused it right now, there's really not that much. Okay, next one. We have this graph, percentage of cumulative doses given by manufacturers. So this is for all of our counties. And then we have it sorted by manufacturer. And then in the specific cells, you can see the percentage. So we're going to talk about how to make heat maps too at some point. They're really, really simple though. You just supply basically your ticks here, your ticks down here, and then just your data. That's it. And then we have another one for Moderna, and then there's also one for Pfizer here. And the other graph is here, percentage of doses administered for the doses distributed. So basically, are these counties, are they using up all of the doses that they're given? Alright, so that's kind of a preview. We'll talk about it a bit more too once I get the deliverables up. Yeah, the code will be similar for you, Nathan, for the first project. I mean, yeah, of course you could just copy and paste and modify it as needed. Yeah, because you used a for loop, so yeah, you could do that. Alright, there is going to be some different things though, because the indices for these counties, they aren't the same length, so you guys got to be careful of that. Before we used cell array, so you could do that, but the differences in the amount of indices, that's going to be something that you gotta take care of for this project. And I'm going to make some more supplemental videos so you guys can feel a bit more prepared too for the project. Alright, so let's go on. Didn't mean to close out my webcam. Let me get that back up. And then we're going to start our new stuff. What is my background? I don't know. I just got a random background. Okay, so let me get my slides. Again, sorry if it's scattered today. So we left off last time on nested for loops, where we made this array or this matrix by using nested for loops. So you can do that. You can use nested for loops for a lot of things. For the project, I think I used it one time, if I remember correctly. And today, what we're going to do for our example, we're going to use a nested for loop as well. So we're going to go over this example before we go over the kind of real life example, okay? I'm going to make a new script. Yeah, it's fine. Oh yeah, I saw for multiple people, so I'm not singling anyone out, but some of you for your code, you guys don't type in clear and CLC at the top. Make sure you do that, because when you, like if I ran my code right now and I didn't have this, first I need to save it. Okay, so if I run my code, everything over here in the workspace is still staying there, so if I was now gonna reference T sometime in my document, it would be referencing this table, or it would be trying to reference this table. And then we would get an error, so you always want to make sure you start out your script with clear. And then I also type in CLC just so I can clear out the command window, because that can get kind of annoying too. Where's font? Font. Okay, that's fine. Didn't mean to close out of that. I keep doing that today. Sorry. Okay, here we go. Let's make this for loop again. So this is what we did last time. Okay, we're going to make this matrix right here. So we're going to use a nested for loop. Do we need to use a for loop to make this? Of course not, but we're just showing how to use a for loop. One example. Okay, so we have 4 rows and we have 4 columns. So the first thing I'm going to do is say for I equals 1 to 4, and this is going to represent the rows that I have. It can also represent the columns, but for how we're making this right now, I'm going to say that it's going to represent the rows that we have. I could put a little comment there, rows. Okay, then we're going to say for j equals 1 to 4, because I want to have 4 columns. Okay, and then we're going to say if I is equal to 1, so if I is on the first row, or basically if we're on the first row, or if I equals 4, so, or if we're on the 4th row, or if j is equal to 1, so if we're on the first column, or if j is equal to 4, so if we're in the 4th column. So if we're either in the first row, 4th row, 1st column, or 4th column, then we're going to say, make that a 2. So a sub I comma j equals 2. Okay, let's close this out for now. Let's also initialize this array too. Let's type in A. So, see here that it made our matrix, right? But if I hover over A, it's going to say that the variable A appears to change size on every loop. So basically, I think we talked about this too before. But if I currently run my code, so I put a breakpoint down on here, and then I'm going to click on run, and I'll say, I'm going to go step by step. So in our first loop, we get a value of 2. So basically that put our value of A 1, 1, so the very first index. And if I continue to loop, we get our first row. Keep going. Now we're building our second row here. Keep going, there's our 3rd row, keep going. Now it's gonna make our 4th row, index by index, there we go. Alright, so that entire time, our matrix A was growing in size. So when you do that, it's really inefficient in Matlab, because it's basically recalculating the size of the matrix that you're making. So to make your code more efficient, we want to initialize the array, or basically specify the size that we want our matrix to be. So I'm going to say initialize array, and this will be something that you should be doing on your second project for sure when you're using the for loops. So we're going to say a equals zeros of 4, 4. I think we can also say a equals zeros of 4, and that'll make a 4 by 4 matrix. But I always am explicit with the size I want by defining both the amount of rows and the amount of columns. Alright, so now if we run this and we go step by step here, you're going to see, once we calculate this now, that's our first value, but the size of this matrix is already defined. So all of the other values are already in here, and we're going to update them as we go pass by pass. Okay, so again, that's just to be more efficient. I think one of our slides, we actually compared the amount of time it took to run when we didn't initialize our array. Or maybe that was for something else, I'm not sure. Okay. So let's go there, stop, let's run this again. So we have our values for 2, but I also want to include the those kind of inner values for 1. So to do that, we're gonna just say else a of I comma j is going to be equal to 1. Now let's type in A, and there we go, there's our matrix. Alright, also you'll see there's little squiggly lines here. Okay, so it says when both arguments are numeric scalars, then consider replacing it with 2 of those vertical lines for performance. Alright, so we can do that too, and that's going to help make this faster. So this is a short circuit OR, it's called. And that's when, if this is satisfied, then it's going to move on to do this one, and then it'll move on to do this one, and then it's going to move on to do this one. So again, basically though, it's the same kind of thing. We're saying if we're in row 1, row 4, column 1, or column 4, then we're going to make all of those values a 2. Okay, if you want to break this down kind of step by step, then you can do that as well. But we're going to go on to our exercise for a more practical exercise for looping. Okay, I know we did one before, also I think last class, but we're going to do a few examples this week because I think doing these kind of real world examples is more useful than making like just some completely random matrix. Okay, while loops, we're going to talk about that probably later this week. We're only going to talk about it for a little though, because we don't use them too much. Alright, so I'm going to close out of this, and we're going to work on our example. Also, fair warning, I don't know how long it's going to take. It's not that long of a script, but usually, you know, when I do these examples with you guys, it still usually takes a while because I want to explain everything in detail. But just fair warning, I'm not sure how long it's going to take. So the data, if you want to follow along on with your own Matlab installation, you can go on today's page and click on picture data, and you can get that. No, you guys can, for project 2, you can do absolutely anything you want. So for project 1, I didn't allow you to use a for loop. But for project 2, you can use absolutely any method that you want to use. If you can still get your code to run correctly, then that's totally good. So yeah, use whatever method you want to use. You are going to have to use looping for this project though. Okay, no, not hard coding, no. I'm going to mark you down on hard coding. And hard coding is just a pain in the ass really for you if you're trying to debug stuff too. Alright, I'm going to make a new script again. Okay. So let's call this picture example. If you are tired of the baseball data, sorry. I was thinking about getting different data, but it was getting way too late last night when I made this example. And baseball data is just really easy to get to. It's so convenient. Oh, that was funny. Okay. I'm going to tuck this over here like usual. Okay, so first thing we're going to do, input our data. I'm going to go through the stuff that we know how to do now really fast. I want to focus on the looping part. Again, this is going to be a nested for loop example. So, import our data. Import data. I'm going to call it T read table. My data is back a directory, and then it's in a folder called data. Select pictures 2021. .csv. What did I type wrong? Oh. Pictures. There we go. Alright, so let's take a look at this really quick. Just see what it looks like. It's like the other spreadsheets that we have. It's a ton of stuff. We have 2,000 rows, basically, and we have 92 columns. Alright, so we have a lot of things here. We're going to make one plot here. So what we're going to make in the end is a plot for the pitch spin versus pitch velocity. You don't need to worry about what it is too much. I just want to show you guys the method, right? But pitch spin is how, how many RPMs a ball has when it's thrown. Let me run this and show you what it looks like again. Okay, so we're going to make this, and dang it. Okay, we're going to make that graph. Okay, so I forgot to put in my X labels and Y labels, sorry. On the X-axis, we have the velocity. On the Y-axis, we have the spin rate. And we have it for 6 different pictures here. So we're going to use a nested for loop. Oh, and this is frozen too. That's nice. So we're going to use a nested for loop to make this picture and the other pictures that we have. Okay, don't freeze now. The datasheet is on today's page. So go to today's page on Canvas, then there's a link for the data. Alright, so we're going to make that graph. Let's go back here. And let's finally get going. Okay, first thing, we want to get those unique pictures that we have. So this will be something that you use on the project too. You got to use the unique function. And let's call this player equals unique. And we're going to access our table T and then get our players. Player name. Alright, we got our players. And I'm also going to actually convert this to a string. So I can just say string right here. Converting it to a string because later we're going to use a logical operator with it. So I need to use a string. Okay, then we want to get the unique pitch type. So was it a fastball or a changeup or a curveball, something like that. Call this pitch name equals, again, I'm going to convert this to a string. So string of unique and then pitch name. Alright, so we have 2 metrics here, right? We have these individual players and we also have these individual pitch types. So one method you can use, there's going to be multiple methods for handling this data, but we're showing a nested for loop here. Our first for loop is going to basically sort our data by the player. And our second loop is going to sort it by the pitch type. So basically once we loop through this, I can look at each player, and for each player I can look at their pitch type. And from that we can get their spin rate for each pitch type and their velocity for each pitch type. Right, so initializing our arrays. We're going to do this, right? Like we talked about. So initialize arrays for the indices. So we're going to have to find the indices for all of our players again, just like we do on the project. Now we have 2,000 rows. I need to find the indices for each of these players. So in the beginning, we see it's just one player, but he's going to show up later throughout this spreadsheet a lot of times. Alright, so we got to find all of the indices when they show up. So I'm going to initialize this by saying player IND. We're going to make it a cell array as well for this example. And I want this cell array, by the way, this is how we make an empty cell. We say cell, that's the function, and then say what the size is going to be for that cell array. Alright, so if I run this, and let's take a look at it now, we see that we have an empty cell here, or empty cell array of 6 cells. So basically, each cell here is going to contain all of the indices for each player. So number 1, this will contain all of the indices for a first player, number 2 for the second player, and so on. And we're using a cell array here because, remember, a cell can contain its own array. So if this first cell contains an array that is a length of, let's say, 500, the next cell can contain an array of some length of like 300. Doesn't matter that they're different, we can keep them in this cell array because it's a cell array. If we tried doing this with a matrix, it wouldn't work because the lengths for all of those indices are different. We can't have a matrix with different lengths. Okay, so that's our player indices. Now we need to also initialize an array for the indices for each type for each player. So let's say player name, or sorry, pitch name, cell, length of player, length of pitch name. Okay, so let's look at what this is representing. So here we have a 6x8 cell array. Currently it's empty, and what this represents, our rows here, they represent all of the unique players that we have, and the amount of columns, 8 columns, that represents the pitch type. So if I look at row 1, that's going to be for our first player, and this first column here, so basically this cell right here will contain all of the indices for a first player for that first pitch type. Okay, and then all of the indices for a first player for the second pitch type. Once we start running this script, you can visualize it a bit better. And let's do pitch velocity, and that'll be the same size here. So length of player and length of pitch name. Okay, and then we have pitch spin. Alright, so that's all we're going to do for now. I know there's one more. We'll get to that later for the legend. Alright, so now we're going to start looping. So, yeah, I'll explain the format for the arrays once we start looping. Because, we just specified the size for the arrays, but why it's that size, that'll make more sense once we start looping here. Okay, so our first loop is going to be for, why do I have a comment? Okay, we're going to say for I equals 1 to the length of player. So I want to loop for every single player that we have. And the length of player, that's 6. We have 6 players. So I'm going to loop 6 times for this outer loop. Okay, then we have for j equals, actually let's not do that quite yet. Let's find our indices right now for each player. So we have 6 players. I want to find all of the rows when they show up in our spreadsheet. Okay, so we're going to call this player IND, and we're going to save all of these. Do you have to? No, you don't. So we're going to save all of the values here, So I want to have I rows, and I want to have 1 column. We already specified the size for this earlier on. Remember, we said player ID equals cell length of player, comma 1. That's what you see over here. It's an empty cell array of 6 cells and 1 column. If I didn't initialize that array, oh, there. Okay, so if I don't initialize that array, we're gonna get a squiggly line here. Let me run our code. Comment this out and do that. Okay, once I fully type out the line, we would get a squiggly line here because we're going to be building that. It's going to increase in size as we loop. But we want to be efficient, so we're going to initialize that cell array. Alright, so let's find all of our indices here. So we're going to say find when t.playerName. I'm using the find command because, again, that's easier to visualize. And the penalty for computational cost is going to be pretty low for this spreadsheet. So I want to look at our table. We're going to look at the column called player name. And we want to find when a row in player name is equal to each unique player. So equal to player of I. Alright, let's run this. Also, this is why we converted player to a string up here. So if I delete this part here, now we get an error. So if you saw this error on your project, that's why. So it says operator equals is not supported for operands of type cell. We're looking at player names, so they're words. So we need to convert that to a string, and then we can run that logical operation. Alright, let's take a look at player ID. So you see that all of these, they're different lengths because for each player, they show up a different amount of times in our table. And again, if I tried making this a matrix instead, we'd get an error because these lengths are different. So let's look at our very first one. So this is going to correspond to, if I type in player 1, it's going to correspond to Shane Bieber. Alright, let's check if these indices are correct. So when you are typing out your code, and like for your project, you want to make sure that whatever code you typed out is actually correct. So kind of break your code down, especially in your for loop, and make sure that it actually makes sense. So here this is telling us that for our first player, Shane Bieber, he shows up on rows 1 through, I think it's quite a lot in the beginning here, 1 to 119. Let's see if that's correct. And he continues to show up later on, like on row 535 and so on. But he is going to be in those first 100 rows. If I look at player name, there he is, Shane Bieber. And he stops showing up here on row 119. Is that what our indices said? Let's go to scroll down. We see 119, and then he shows up again on row 535. So that looks good. Let's just check another player too. We know it's working now because we're just looping. But let's just check out another player too. Let's do player 5. We have Shohei Ohtani. He's pitching today, by the way. And he's going to show up the first time on row 320. Let's check. Row 320. There he is, Shohei Ohtani. Oh boy. Player 4. I think I might know who that is. Yep, no. I'm gonna say no. Well, you're kind of true, or you're kind of right that he is the GOAT, but whatever. Alright, let's keep going. Okay, so our indices look good. So let's move on to the next part. We have all of the indices now. Now we want to break this down for each player. I want to find when they threw like a fastball, a changeup, and so on. Hey, I'm not hating on him. Well, I have to kind of hate on him because I'm an Angels fan. But I can't deny, he's good. Okay, so for J equals 1 to length of pitch name. Okay, so now we're going to get, for each player, we want to find the indices for, again, when they threw each pitch type that we have. So now, we're sorting this by player name, and now we're going to even sort it more kind of granularly by pitch name. So we're going to use a nested for loop now. Okay, let's make a little comment here that says indices by type. Okay, and then we're gonna say pitch name, IND, which we already specified the size for up here. If I want to look at the size, I can do that. So this will give us all of our indices here directly. We're gonna save them all. We're gonna say find one t.pitch name. So we're gonna be looking at the column called pitch name, column 79. We're going to see when that is equal to each unique value and the array that we called pitch name. Okay, so I want to find all of the rows when it's equal to a forcing fastball, a changeup, a curveball, and so on. But we also want to check when this is true for each unique player. So we're going to use array addressing now for the indices that we just found. So player IND. And then we're going to say equals to pitch name of I. So I'll break this down again, don't worry. Okay, so on this line of code, what we have is we want to find all of the indices for each player when they throw some specific type of ball. So we say find when t.pitch name for our player indices is equal to pitch name of I. So we're saying, let's say, actually this will be easier to look at once we kind of loop through it. I'll do it that way instead. That'll be better. Let's go here. Okay, so I created a breakpoint. Again, I just click on here, and I'm going to click on run. And let's go through this step by step. Actually, let's go out. Okay. So the first thing it's going to do is calculate our indices, right? So currently they're empty. Let's press step. Now we have all of the indices for a very first player. We're in this first outer loop here. So it got all of the indices for a very first player. Next thing we're going to do is move into our second loop here. And we're going to find all of the indices for our first player for all of the pitch types. So now we're in this inner loop, so we're going to find all of the indices for the very first pitch type. So this cell right here, that should fill up. Okay, so there it is. So we have this fills up. Let's take a look at those indices and let's make sure that this line of code is working like we would expect. Okay, so the first one we see is 5. Let's go in our command window and let's type pitch name of 1. So that's a four-seam fastball. And then we also can do player 1, that's Shane Bieber. So our code right now is telling us that Shane Bieber is going to throw a four-seam fastball on all of these rows in our table T. So let's make sure that this is correct. Let's go to row 5. Row 5, four-seam fastball. Row 7, four-seam fastball. Also good. And we know that that was Shane Bieber. We looked before, but we can, double check. There he is, Shane Bieber. Looks good. Okay, let's check our random index. Let's go to row 259. So row 259 in our table should be for Shane Bieber, and it should be a four-seam fastball. 259. Oops. 259. Uh-oh. Nope. No, that's not good. I'm missing something then. Let me run this again. Okay, let's look at the first few ones here, and then let's make sure. We'll go like that. Okay, so 5, 7, we already checked that. Let's check row 11. Row 11, forcing fastball. Let's go to 102. Forcing fastball. Did I miss something there? 252. Forcing fastball. And what did I say? We just looked at 259, right? Yeah, why? There's something wrong here, something I'm missing. Okay, that's not good. So I'm gonna have to look at this, guys. What is on the right of the code? Over here? That's just our workspace there. Or if you're trying to look at all of the code at once. So yeah, this should be for a fastball, and it should be for our very first player, that's Shane Bieber. And we're using the indices for our very first player. Okay, that's something I'm gonna have to look at. So basically what I'll do is I'll take a look at this and I'll make an update today, and I'll post that video. And it's often the small things, like a lot of you have probably found out from your first project. Okay, let's continue stepping through, and let's look at the other players, and we'll kind of see what that looks like too. And let's look at this. That's a size of 531. Let's do some of pitch name IND. Okay, I want to look at the first row and then all of them. Can't do it that way. Alright. Okay, yeah. I see what's going wrong now, kind of. It's you know, all of these are the same exact size. They shouldn't be, because he's going to throw a different amount of fastballs and a different amount of curve or change-ups, curveballs, and all of that. So, yeah, there's an issue there. Again, I'll look into it. I know what the issue is now, at least, so I'll debug it to where this is only looking at each specific pitch. But I think the graphs in the end are actually okay. It's just basically I'm storing more data than I need to right now. Okay, so let's continue here. Even though we know that we're storing too much data, if I continue to step through though, then we'll see that all of our indices here for pitch name ID, they're going to continue to fill in. So if I keep going, and it just did our first row, and then it's going to go through our second row, then it'll do our third row, and so on. Okay, the next part, we want to look at the velocity, and then we want to look at the spin rate. Okay, let me save this. Let me open up my other script real quick. Let's see if I have the same thing here. I don't think I typed anything different. Oh, I did, yeah. Okay. So I typed something different somewhere. You see here, this is actually correct. So I did do it correct earlier. You see all of these lengths, they're different, right? And for what we just had, they were all the same. So there's something wrong there. Let's take a look again. Sorry, this is an off day. So we were here. And there's something that I typed different than my code that I'm looking at on the left. Yeah, so again, it's a small thing, right? A lot of the times when you guys send questions, you know, you see like I'm getting this error and our code looks the exact same. It often does look the exact same, right? But there's a small difference. And that's what's going on now. I can't see the difference right now, so instead what I'll do, I'll get the script that I made earlier, and we'll take a look at this. So you see here, our lengths for each pitch type, they're different. So let's go back to where we were earlier. So we're saying that in this first row here, we're looking at our first picture, that's Shane Bieber. And then for column 1, that's... Oh, I didn't see your question, Brianna, sorry. But yeah, I'm going to take a look again after class for whatever the small issue is. So we have the first row again, that's going to be for Shane Bieber, and then column by column is going to be for different pitch types. No, so this part here, this is, I'm just changing this just to not look at every single pitch type. I can comment this out for now too. And you see all of that stayed the same. Now I'm just going to get more graphs. You see, I just got 8 graphs. That's why I did that earlier. I'm actually going to change this to 2, so I only plot 2 graphs at a time. Alright, so let's keep looking at this. Alright, so this is again the correct one. This first column, this is for Shane Bieber for throwing a 4-seam fastball. Let's look at the very last index, and let's make sure it's correct this time. 534 in our table. That's why you also want to check too. If you make a mistake like I did, then you want to make sure you catch it. 534. 534, that's a 4-seam fastball. And wait, wasn't the one 259? Wasn't that it? So maybe there still is an issue in this code too. 259. Yep, slider. Okay, so there's even still an issue here in this code. At least these are different lengths, but this shouldn't be 197 values. Okay, so embarrassing that there's an issue in class, but I guess in a way it's almost good because it proves why you need to double check your work. Because there's an issue here. Alright, so for like your project, right? When you guys find your indices, do what I'm doing right now. You want to make sure that all the indices that you found actually correspond to the indices in the table. I'm thinking, because I don't want to like continue to say anything wrong here. So I don't like to end class early, but I think I might end it early just because I don't want to say anything wrong for the rest of this script here. So I think I'll probably do that. I guess until the end, if you guys have questions on the project, you can ask them now. Or you're free to go, so I'm sorry I'm cutting it early. Again, I don't like doing that, and sorry it's at a really off day compared to usual. But I'm going to end it early, just so I don't say anything wrong here in this script. And I'll see you guys on Wednesday, and hopefully that's a better, more normal class. So yeah, you can ask questions about the project now if you want to stay. And remember, there is no quiz on the homework today. There's still a quiz, but it's due by 11:59 p.m. tonight. It's going to open up actually right now at 3:30.
Yeah.
Yep. Yeah, so I'll see you guys on Wednesday. Sorry again. It was an off day.
Hey, Professor, I have a question.
Okay, let me stop recording.